Variable speed drives. We tried these in the 80s and we failed miserably. We burned them up, tore them up. We tried again in the 90s, and now a few years ago we finally have got them to stick. They've always been used in heavy crude situations to where the rods just won't fall through the heavy crude. So they slow it up on the downstroke and then try to speed it up, trying to match it. Well, the theory on this is slightly different. Now what you're doing is you're setting a dead band. So on the downhole card, if it goes on this side of the dead band, it says, I have fluid pound, slow the well up. If it's on the other side of this area, it says, I have extra fluid, speed the well up. Well, you get to set this area. You get to set, do I change it every stroke? By how much speed do I change it every stroke? You also get to set the maximum and minimum speed. So again, we would like you to take one of the rod design programs and verify that rod string, how slow and how fast can you run it to get the proper window. But this is not for every well today because of the premium cost of the drive, but we're seeing some amazing results on these that we were surprised. So why would you use these? Well, if you're just having really a problem matching that pumping system to your reservoir, the drive will do it. It will reduce your rod loads, rod stress, rod float. It can increase production because we have found some wells that no matter how long you try to leave it down, that little bit of downtime holds back pressure. And if we keep that pumped off, we'll see if we get any surges, any additional fluid. Now, we do have seen an extreme amount of maintenance cost reduction, which has surprised us on some wells where we had controllers, they were still having some rod failures, but by going to the drive, it has softened that speed and that fluid pound to where we almost don't have any fluid pound strokes. We keep fluid in the pump at all times. Electrical costs, you're normally not going to see any savings because you may be cycling your well. What are you running it? 70% of the time? This is going to run 24 hours. So you will use more power. It may be more efficient, but you may have a higher electrical bill. One of the things you do need to note, though, is most pumping units, the gearbox is gravity fed. So the oil on the gear is fed to the next gear with gravity on the gears. If you run it real slow, the oil may fall off that gear before it gets to the next gear. So they have things called wipers in gearbox that scrape the side of the gear that help put the oil to the next gear. So if you do go to anybody's variable speed drive, check your gearbox. Gearboxes are about 60–65% the cost of a pumping unit. I'd hate to see you try a variable speed drive and burn up a gearbox. Some of the things that we've always gotten in trouble on of why we look at drives is first is sanding, pump sticking. People say, I can't cycle my well. If I stop it, the sand falls out of the fluid, I stick the pump. Well, now you can do that with a drive. The heavy crude and rod fall, we've got programs that when it starts to see that rod float, it slows up immediately. And we can take a big rod float down to hardly nothing, which has been amazing that we have raised production on some wells in Oman that they had about a 50% rod float. It was horrendous looking. These are big units, and half the time on the downstroke, because their steam flood is erratic, they'd get about half the stroke, the rod just sat there, and here it comes on the upstroke, bam! Well, when we adjusted it to let it get the full stroke, we actually doubled their production just because you got double the pump stroke now. Large volume producers, we've seen some wells in level land that when they actually have a well go down, have to replace the pump, they may have to run 2 weeks to pump enough water to get back to making oil. So with a drive, you can really crank that speed up and try to pump that down as quickly as possible to try to get back to making money. And then the low bottom hole pressure wells. Those are ones that we have found over the years, boy, we want to put a rod pump controller on there, but we find that bottom hole pressure is so low, any little back pressure, we hold fluid back. So we really almost cannot cycle the well to get it all. But in the past, what you find is they're out there just pounding all day long because they got about 50% pump fillage. It's not enough to fill it, but if you let it come up any more, it holds the reservoir back. And then shiv changes. I mean, there is a cost to go and change shivs. It's not that high compared to a drive, but if you're doing it a lot, there are some issues. Again, what we were talking about earlier is we really don't see any savings on electrical. You can use these on single phase. But the other key is NEMA B motors. We're starting to see people look at this. Now, NEMA D has slip, so the pumping unit can start. A variable speed drive has that same type slip built into it. So we can go to a NEMA B, which has very little slip. Slip means energy loss. So if you go to a NEMA B motor, maybe you can save power. Now the concern is, if you take the drive offline, will the NEMA B start your well? And that's some arguments that are going on. We have one customer that is using 1 horsepower larger NEMA B to make sure he can start the well, and he doesn't seem to be having any issues. We've got a lot to learn yet on motors, I think. One of the concerns is, should we really be using a true inverter specified motor? It doesn't seem to be any issues, but those are some things going around in the market. Here's your typical layout with the inverter. So now all you're doing is you're bringing the 3-phase into the inverter. The inverter is actually converting it typically to DC and changing the hertz. So typically you're at 60 hertz. If we change the hertz, it's going to change the speed of the motor. The motor is just like a bunch of magnets, and it's turning on and off at 60 hertz. If we change that hertz, it turns the magnets off in a different way, and the rotor spins at a different speed. So all we're doing is changing the hertz to the motor. So it's truly a variable frequency drive. Some people call them VFDs. Chevron likes to call it an ASD for adjustable speed drive. We've called it variable speed drive just to not get anybody confused about frequencies. One of the things we just want to warn you is a lot of people are taking inverters and they're throwing them into a regular pump panel. These babies put off a lot of heat, and you need to make sure that you have followed the manufacturer's heat exchange calculations, because you will burn one of these up if they are not vented properly. The other thing that we have seen is most wells will never be properly counterbalanced, and you probably are never going to be able to control your utility on changing the power. They just aren't great about giving you the same power all the time, are they? So what we have found is that we have to use dynamic braking resistors. At times, the pumping unit is driving the motor during a cycle. So when we see that power come back into these inverters, they will take so much of it, and then they're either going to turn off at that point, or they've got to put that power off. Now you try to feed it back to the motor to speed up a little bit, but you can only do so much of that. That's a regen. Normally what you do is you put it to a bank of resistors, and it looks just like a big old heater. And it's just burning up that power so that we can continue to run the unit. Gas engine control. We don't do a lot of this. You can go out on a gas engine and you can simply just short it out if you see a pump off or a malfunction. Or you can go to some of these new clutch systems. Arrow has an auto start. There's a company out in Farmington that has a bladder clutch that we can cycle the well. And all you do is basically hook up a battery, and most gas engines have an alternator, so we charge the battery, and that's what powers the controller. You could also do a solar panel and power the controller. There's been some people that have done a 2-speed operation where they just use a governor, and they get the gas engine with a governor, and basically they pump a high speed and a low speed, so you're over pumping and under pumping with a controller. Or you can just monitor them only. So there are ways of looking at gas engines. There are more expense, and honestly, most of them are cut to fit. You're going to have a mechanic involved. You can look at, with your utilities, on actually trying to get some power savings back from the utility on discounts. They used to give us interruptible power discounts. They're not really doing that anymore, but some of them are giving peak energy discounts, that if you reduce your power during a certain part of the day, you can get a discount. So these controllers all have real time clocks in them. You can actually shut the well down for a little while. And it usually doesn't hurt you if you shut it down for your downtime for a little while. Fluid builds up, turn back on, pump the fluid off. It didn't cost you anything, just saved you some utility discount.